In this video, we're going to talk about finding circumference and area. Particularly, we're just looking at circles now. So I wanted to share with you a few pictures that I thought were interesting, real world, make us think about who uses circles, because sometimes it does surprise you when you start realizing how much math is used in the real world. So this kind of thing I saw when I flew from Florida to Seattle. I had to go to a conference for work, and we had to stop over in Colorado. So I like looking out the window and seeing, hey, what's it look like down there? And it looked like this. And I was like, oh, that's different. So I want to show you some other views of what it could be. I wish I could say that I took these pictures myself. I did not. I took these from the internet. But I did want you to see that there are different shapes and sizes, and it's very different looking than what you're used to looking when you look out the window in Tampa when you land. You see water and stuff as we're coming in. But you look out at Colorado and you see geometry, and I love it. So here's what I found out later is these circles are created by long sprinklers. They come from a central point, and so clever name, central pivot irrigation is what's going on here. As a mathematician, I wondered, well, what size circle is the best, right? If their idea is to use these for crops, don't you want to cover as much area as possible, get the biggest bang for your buck here? So should you be doing like these little small circles, or should we do one big one? Every once in a while, I notice, like, let's flip back a little. Sometimes there's these half circles. My favorite are these Pac-Man looking things. Sometimes you'll get like a Pac-Man with another little circle in there, but definitely something to be thinking about, that farmers are doing different shapes, and you gotta wonder, well, how come? What's going on? So we need to start back and just talk about circles in general. Circles are something I'd love to talk about in all my classes, because when you start talking about math and how important it is to have videos and resources, it's because math is a different kind of language almost. A lot of times in class on the first day I'll ask students, I'll say, well, tell me what a circle is. Like, give me a definition. And as much as it's such an elementary thing for you, you've known a circle most of your life, if you had to give a formal definition, it should create some pause. You should be like, well, it's round. Well, it's got to be more than just it's round. It has 360 degrees. So does a square, right? So math has its own unique little way of talking about things. So definition for circle I would give is that a circle is a set of all points equally distant from a common point called the center. So you can see I have a circle here, and this would be the center, and this distance from the center to any point on the circle would be the radius. So radius is just a word we use to represent distance, and by saying radius, we know we're talking about circles. If you wanted to go all the way across the circle, that's fine, but you want to make sure you hit the center for that to be the diameter. If you didn't hit the center, it wouldn't be the diameter. So it has to go through the center to be the diameter. The diameter is twice the radius. So you want to pay attention when we're talking about circles of which one did I give you? Did I give you the radius, which comes from the center, or did I give you the diameter that goes all the way through? Just in general, and let me draw this for you real quick. If I just went point to point, so if I just went across a circle and I didn't go through the middle, we call that a chord, C-H-O-R-D. In chord, you probably think music. Completely correct. So still that idea. Math has to do with everything. Like, that's what I'm supposed to teach you. Definitely a lot of mathematics and music. So that chord that you're thinking with music is exactly that same kind of chord I'm saying right here. That doesn't go through the center. All right. So let's start talking about like area. The area of a circle is pi r squared. Pi should be on your calculator, so I need you to spend some time trying to locate that pi button. Get familiar with it so you can use it throughout this chapter. If you have to, you can always take a screenshot of your calculator and see if I can find it for you if you really can't find it. And you should hit it to see, like, what does it give you. Different calculators are going to give a different number of digits for pi. Pi goes on forever, right? There is no, like, somebody has got the value for pi. It goes on, there's nothing. There's a book called A Million Digits of Pi, and it's just that, a million digits of pi. It just has a bunch of numbers in it. So here's what I got when I put in my calculator. I got 3.141592654. I'm not asking you to memorize anything. I'm asking you to use your calculator. The homework is a little weird sometimes. Sometimes it'll tell you use the pi button on your calculator. Sometimes it'll say use 3.14. Make sure you do what it tells you to do in order for it to give you the right calculation. If it happens to be a multiple choice problem, pick the one that's closest to what you get, but do pay attention to what you're supposed to do. All right. So let's go back to talking about that central pivot irrigation system. So with a little research, I found out the maximum radius of each circle is 1,600 feet, which is really long. It's about a third of a mile. Think how heavy that is. I think that's really impressive for a sprinkler to be 1,600 feet long. So let's assume the larger circles in the pictures that I found had a radius of 1,600 feet, and this would mean that the circle lies within a square that would be 3,200 feet by 3,200. How did I get that? So let me draw you a little thing. This is going to be really an awful drawing because I'm not a good drawer, but you're thinking I have this circle. I'm doing really better than I expected to right now. So if this is 1,600, that's my sprinkler. Just extend it all the way through. There's 1,600. And it would be the same in any direction. So 16, 16, there's my 3,200 this way. And it would be the same this way, 3,200. Okay, so let's get back to what we said. So using this formula, I get pi r squared. So pi, which we know, 1,600 I square it, which is 8,042,477.19 square feet. Wow. And I want to compare that to breaking up the same square into 4 small circles. So this would be the area of a big circle, so that big circle we saw. But I said, well, what if I break it up? So instead of having this one big circle, what if I used a little circle that went in the corner? So the radius of the large circle is 1,600. So that says this is 1,600, which means that would be the diameter of this little circle. So if I break that up in half, this would give me 800 right here. So 1,600 here, half of that 800 is the radius of my small circle. All right. So I take that 800, I square it, I multiply by pi, it gives me 2,010,619. That's for little one. All right, let's see how this little one, I would have another little one, and another little one, and another little one. So I would have 4 of them, which is 8,042,477.193. Let's click back a minute. So remember, 8 million. Let's click back. 8 million. See how it's the same? So it doesn't matter if I have this one big circle, if I have 4 tiny little circles, I'm going to get the same area. So I think it would really depend on if you want to buy a really big sprinkler or if you want to buy a little sprinkler as to which area you really want to cover. So I thought that was kind of cool. The area covered is independent, whether the farmer uses a big circle or 4 little ones. All right. So then there's this other thought of, well, how much land are you wasting? Right? What are you not watering? What are you not getting to use and irrigate and produce on? So let's talk about the area of a square. It would just be length times length, so x times x. So I have this square outside with this circle on the inside we were talking about. So the circle is inside the square, and the area of the square with the side length of x. So we already said the square was 3,200 feet. I square it. Now I have 10,240,000. Here's my area of the circle, or the 4 circles, either way. And it says, I have a lot of land that we are not using when we use the central pivot irrigation system. So this 10 million, I subtract the 8 million, and I get 2,197,522.807 square feet I'm not using. That says that's a lot of waste, like a big percentage of land that you're not getting to use. So it makes me wonder if this is the best way that they could do it, and maybe that's why we don't see it in Florida. Who knows? Not a farmer. So let's kind of keep going talking about circles. Other things we need to talk about circles is circumference. And circumference is how far around is it when I go in a circle. So I like this arrow to kind of show you it's around. Circumference is 2 pi r, or if you want to do pi times d, that's the same. 2r, so twice the radius is the diameter, so you can pick which way you want to do it. Just pay attention. I want you to note the circumference measures the outside of the circle, where area measures the inside. So keep track of what am I looking at. Outside, go around it. Inside, get inside it. All right, so let's just do some really generic, boring, find the area and circumference of a plain old circle. No crop circles here. So this one has a radius of 4. So I'm going to do the area as pi times 4 squared. So that gives me 16 pi centimeters squared. I'm going to put this in my calculator. 16 times pi, it gave me 50.265 centimeters squared. I will tell you on a test, on homework, whatever, how many decimal places I want. So don't worry about are you going to know which one to do. I'll be really clear with you always. Let's just compare. Let's also do the circumference. So circumference says let's go around this circle. It's 2 pi r. So I have 2 pi times 4. Or 8 pi, but again, using your calculator, I have 25.133 centimeters, right? Pay attention to centimeters for circumference, centimeters squared because I'm doing an area. Also, always pay attention to whether I give you or the homework or whatever gives you diameter or radius, so you know should you be doing 2 times pi times r or should just be doing pi times diameter. All right. So let's look at something all college students seem to love and know, which would be pizza. And I completely took this off the internet because I like to steal stuff from the internet so that way I don't have to make up prices. And so I found this and it said build your own pizza. Awesome. So they had some choices of sizes. So you get a 6-inch for $6.95. You can get a 10-inch for $8.99. Or you could get a 14-inch for $12.99. And then you could get toppings and stuff extra. That was fine. So let's see what has the best price. All right, so I'm going to start with the small pizza, which is a 6-inch. And this 6-inch refers to the diameter, so it's not the radius. So to get the radius, I need to divide by 2, so that's 3. When we're talking pizza, we are talking area, because that's how much pizza do we get to eat. So this area is pi times 3 squared, so I have 28.27 square inches of pizza. And then to find the price per square inch, notice what says first. Price is said first. Let's put the price first, $6.95 per square inch. So I put how many inches underneath, and it says it's $0.246 per square inch. Okay, so let's keep comparing to say, hey, is it cheaper per square inch if I were to buy medium? Medium says 10 inches. Make sure you remember that's diameter. Divide by 2 to get the radius. So now that I have the radius of 5, I can square it, multiply by pi, and I get 78.54. Okay, again, it's price first. So the price, $8.99 per square inch, 78.54, which gives me 0.114. All right, so already I can see my price per square inch is cheaper if I go to the medium instead of the small. All right, so I want you to try to do for the large pizza and say, hey, is the large even a better deal? So find the area, find the price per square inch, and let's see what's our best deal here. So pause me so you can do that, then come back. All right, so let's check out what happened. 14 was our diameter. We divided by 2 to get the radius, so now that's 7. I square it, multiplied by pi, I got 153.94. So here's my area. Again, price first. So my price, $12.99. My area, 153.94. When I divide, I get 0.084. And definitely we can see this is the best deal of the 3 choices. What I also found interesting about this ad is the cost for additional toppings. So I just want you to take a look at it. Do you see it right here? Additional toppings, 0.99 cents and then 1.25. Honestly, I don't know. I'm guessing it's more for the large or something. But here's what I want you to think about. 99 cents, right? Look how I wrote it. 99 cents is 99 cents. It's almost $1. Cool with that. But what about 0.99 cents? What is that? Well, it's really almost a penny. It looks like somebody made a mistake because nobody is charging you a penny per topping. Or if they are, awesome, please tell me where that is because I definitely would like to order toppings at that place. This is an issue I see all the time, and to me it's an issue of math literacy, just knowing what's the appropriate unit to use where. Legally, you could force them to only charge you a penny for that, which again would be cool. I stole this off the internet. I did tell you that already, but it wasn't from Tampa. So sorry I can't send you where this was so that you can go get really cheap pizza. But it did say be a good consumer and also be good at what you do in life, that notation does matter, not just in English class, in all classes, including math. All right. Let's keep going. I just want to show you a little bit of what else this could be used for besides pizza that we love, but cars we also need. So I wanted to show you just some quick applications, that things that you don't think about geometry being important. And one thing I think is important is speedometers, because that keeps us from getting in trouble, right? It tells us how fast we're going. So speedometers are designed to gauge the speed of your car based on the tires it came with. Right? So when they engineer these cars, they know exactly what kind of tires they're going to put on, what size they are, and then that helps you measure how far you go. So I want you to think of tires and the speedometer as a match set. If you change the size of the tire, you've changed the accuracy of the speedometer. So what happens if you change the tire size? Well, since the speedometer is paired with the tire the car was made with, the speedometer is in effect using the circumference of the tire to calculate the distance being covered. And I want you to think about circumference saying it's how far it ran around. So every time that tire, right, think about that rotation going around, it says here's how far I went. So if I made the tire bigger, that would change things. If I make the tire smaller, that would change things. So let's say you got a smaller tire, and again, totally found this online and absolutely love it. If you get a smaller tire, or if the tires are underfilled, which happens to us all the time, you'll be going slower than your speedometer indicates, because when it does that lap around, it didn't go as far as it was expecting. This is ridiculous. Like, you don't want to buy these tires, obviously. But you would think that a tire with a smaller radius has a smaller circumference and therefore goes a shorter distance when it rotates. That's why we do want to keep our tires filled up to where they're supposed to be. That way when it rotates and it goes around, it's going as far as possible each time, so we're getting better fuel efficiency. We're not doing what this dude is doing, or girl. I'm not going to say this is a guy. This person that's driving this car, I don't know what they're thinking. Hopefully they're just looking for attention. All right, so let's check out this other thing that happens. It's totally normal to see. You get larger tires, right? So now I got this larger tire, and every time it spins around, it's going farther than it thought it was going to go. Here's a problem, because now your speedometer is going to say you're going slower than you're actually going. So you can be speeding without knowing it. This could be a problem. Think that your speedometer says you're going 55 in a 45. Maybe you're actually doing 55 if your speedometer doesn't read right. You can fix that. You can have it matched, right? You would have to have a mechanic do it for you to make it match up so your speedometer still works. So you can switch over to usually your GPS, and then it's using a satellite to tell you how fast you're actually going, just so you don't get a ticket. I hate to see that happen to you guys, or to me. All right. So if you're really interested in this, you can go to the PowerPoint and click on this link. I love the name of it, Roadkill Customs. That's really weird. But it tells you how you could change the tire size and see what it does to how fast you're going, to the calibration, so you could see how it would change what's going to happen to you. I gave you some idea if you want to. This is saying, I know some people are more into car than others. I just wanted to give you the website if you want to check it out. Or if you just think geometry in general, you're like, oh, I didn't realize how much it matters. I gave you another site if you want to look at it too. It says 21 seriously cool careers that need math. Obviously there's Woody from Toy Story, but it's really talking more about Pixar and the mathematics behind computers and computer animation and stuff. So if you get a time and you're interested, please check those sites out.